Hello. I'm making a video about another way to look at polyrhythms. This is not very advanced. I am not a good drummer. In fact, there's 3-year-olds that can drum circles around me. But I haven't seen polyrhythms laid out like this. I'm sure someone's done it, but this is my approach in my video, which no one's probably gonna watch, but here it goes. So the basic idea of polyrhythm is combining two numbers in the same span of time. If you take graph paper, when you learn, I think it's algebra, between like this point to this point, you can plot an infinite amount of distances or points, if you will. You can continually zoom in. You could say like between here, like this is 1, this is 2, then in the middle it'll be 1.5. And between that 1 and that 1.5 is 1.25. And it's hard for me to distinguish, but if you had a microscope and kept zooming in, you could infinitely plot points between these 2 points. And the same thing with a click. You have between that span of time, you could have an infinite amount of pulses. Granted, you get to a point where it's maybe not humanly possible to discern or to make something that fast, but that's how it works. So if you take, and sorry for these numbers, they should be the other way. You'll get the gist of it. Most basic one we know of is 2/3 or 3/2, which is, you can think of that common song you hear in Christmas. It's like Christian or Catholic, like dun 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 dun. That's dun 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 dun. So that's 2 and 3 happening over the same spans of time. And to figure that out or look it out on paper, whatever number you want to make a polyrhythm out of, you multiply those 2 numbers together to get their lowest common denominator, meaning the lowest number that they can both fit into together. So if you have 2 and 3, that would be 6. So for 3 to equal 6, you'd have to have 2 of them. 2 times 3 is 6. So you have 1, 2, 3, 1, 2, 3. For 2 to fit into 6, you would need 3 of them, because 3 times 2 is 6. So you have 1, 2, 1, 2, 1, 2. So where the numbers, so then when you play them over each other, you get the polyrhythm. So like dun, 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 and they always start at the same time. And again, all these rhythms can be moved around. For instance, you could play it backwards. You could start with no beat and 1, and you could start on the and. You could play it backwards. But this is just to keep it simple. Everyone would start at the same time. So you're hitting 2, then dun, 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 dun. Most people wouldn't consider 2 and 4 a polyrhythm, but just for explanation's sake, for simplicity's sake, you can have 4 twice, and then 2 4 times. So they'll meet up. The lowest common denominator for them would be 8. You need 4 2s to equal 8 and 2 4s to equal 8. 4 2s, 2 4s. So we have to go to 10, a polyrhythm of 2/5, 5/2, however you want to look at it. You would have to multiply 5 times 2 together, you have 10, which would mean that you would have 2 5s, 1, 2, 3, 4, 5, and then repeating 1, 2, 3, 4, 5, and then 5 2s. So it'd be like 1, 2, 3, and 1 and 2 and 3 and 4 and 5 and dun dun da 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 dun dun da 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 da. And 5 3, 3 5, one of my faves. 1 E and 2 E. So you'd be counting this as triplet, or I could do 1 E and 2 E and. So 1 E and 2 E and. So depending on what perspective you're counting from, I count from the triplet perspective. Be 1 E and 2. So the second 5 would come on the and of 2. 1E and 2E and 3E. And I'm pretty slow mentally, so I need a visual representation of this to really to grasp it. But 5 times 3 equals 15, so you need 3 5s and 5 3s. And wherever they line up, and since this would be 1E and 2E and 3E and 4E, so the last 5 would be on the 4E. Then that 5E and, this is the third 5, so this is the last 5 you're going to hit. We just leave over 1E and 2E and 3E and 4E and 5E and 10E and 2E, 10, 10, 10, 10, 10, 10. And if you want to get all advanced, you could do 3 numbers. And this could go on forever. But once you get into 3 numbers, you have to, you get to really large numbers because they all have to have the same common denominator. So I did 30. I could be wrong here, but I think that's the lowest common denominator for 2, 3, and 5. I haven't taken a math class in like 15 years, probably more, 20. But as you can see, what is this, 15? This is a total of 30. So 2 goes into 30 15 times. It also, you can also go into it, let's see, 2 times 1, yeah, that's it. So 2, 15, and 15. Here we have 3, and for 3 to fit into 30, that's 10. 3 times 10 is 30. So you have, so for the 3 you would count 10 beats, 10 beats, 10 beats. And 5 to fit into 30, it'd be 3 of them. What did I do here? Wait, 5 to fit into 30. No. 5 to fit into 6. 1, 2, 3, 4, 5, 6. So if you, I'm not going to do this because I've never done it before, but you can imagine you would start at the same time. 5 beats, these would obviously line up. This isn't a very interesting polyrhythm. It's just to visually understand it. These numbers would overlap each other, and then once you get to the end of this meter, if you think of it, and just cycle again. They'd all start at the same time and repeat. You could choose any number you want. You could do like 3, 5, 7, but then the common denominator of that would, I don't know, I'm slow. I have to go look at a calculator. But that's how, another way to look at polyrhythms without musical notation, because drums is kind of, dare I say, a dumb instrument in some ways. Like you can go drum on a log with your hands. It's very primitive. Probably one of the most basic instruments besides singing. So I hope that explains it to some people out there who are curious. It's just another way to construct your own polyrhythms and get a visual representation of it. So as I like to have a visual thing to look at where I can see what I'm doing without like eighth notes and quartered whatever the fuck. So, all right.